Welcome to another video on complex numbers. Okay, so what we're going to do is we're going to talk about argument and polar form of complex numbers. Okay, so this is it. We're going to find the argument of a complex number, and we're going to express numbers, complex numbers in polar form. And after polar form, we're going to go on Euler form. Then on argument, you're going to learn how to draw an Argand diagram with an argument represented on. Okay, so what we're going to learn is the first thing is to understand the argument. It is an angle of a complex number. Then you are going to use modulus and argument together to represent a complex number on an Argand diagram. This is geometrically. Then the other thing, we are going to express a complex number in polar form and in Euler form. Okay, so that's it. Let's get into it. Make sure you subscribe so that you don't miss the next part of this complex number or the next part of this advanced math. Okay, let's learn about the argument of a complex number. Okay, so let's say we have a complex number. We're going to be using this complex number for the illustration today. This is a 3 plus 4i. Okay, this is our complex number. This is our real part, and this is our imaginary part. Okay, so an argument of a complex number, it comes from the Argand diagram. So the first thing we're going to do, let's draw an Argand diagram of this complex number. I believe I've taught about this, so make sure you know about it. If you haven't, please go and watch my video in the playlist, which deals with Argand diagrams. Okay, so let's draw the Argand diagram of this. This is the real part. Okay, so this is an a Gantt diagram of this complex number. Okay, so what we're going to do is we're going to, first thing I told you about is the modulus. Okay, so let's say this complex number is z. Okay, z. Okay, so the modulus of z in this case is equals to, let's calculate the modulus. We just have to say 3 squared plus 4 squared. Okay, so in this case, we're going to see that our modulus of z is 5. Okay, so this is 5. Okay, now let's talk about argument. It is the angle of this line joining the origin. Okay, angle of line from origin okay, so this is the angle from origin of the line from origin to complex number. Okay, so drawing an argument diagram, this is our complex number and this is our origin. Okay, so the angle of the origin of the line from origin to a complex number, okay, measured from the positive axis. Okay, okay, so this angle is measured from the positive real axis. Okay, so the positive real axis is this one. Okay, so this means that this angle, okay, let's call it theta. Okay, this is what we call the argument. Okay, so the argument, this is the angle. Okay, so it is an angle from the origin, this is our origin, or to the complex number. In this case, is 3 plus 4i, and it is measured from the real positive axis. Okay, so this is the positive axis of the real. It is measured from here. Okay, so this is our theta. Okay, so the first thing you have to do is to find the theta. Okay, so this theta is found by saying arctan b over a. In this case, it's arctan 4 over 3. Okay, so after punching this, you get this angle, how much? Okay, now you will just have to draw the Argand diagram and take a look which angle is this. Okay, so this is it on the argument. Okay, so the argument, it is the angle measured from the origin to the complex number, and it is measured from the positive real axis. Okay, so this is the positive real axis. Okay, so it is measured from this axis. Okay, so that was that. Let's go ahead and look how do we represent a complex number on an Argand diagram fully with the modulus, with the argument. Okay, so I'm going to be using another complex number which is different so that you can see our angle from somewhere here. Okay. Okay, now let's talk about representing a complex numbers geometrically. Okay, so when it is geometrically, it is an Argand diagram. Okay, so just remember that representing a complex number geometrically, it is a Argand diagram. Okay, so I'm going to be using this complex number. Let's say it's z is equals to, in this case, it's going to become minus 3 plus 2i. Okay, so I'm going to be using this one. Okay, so the first thing you are going to do is you're going to draw an Argand diagram. How do we draw it? like this. This is the positive real axis, and we are going to draw our imaginary axis like this. Okay, then so now we are going to go in minus 3 somewhere here. Then our 2 is here. Okay, then we join here. This means that this our point is here. Okay, so this means that z is here. Okay, so this is the line to the origin. Okay, so now what we're going to do is the first thing, we have to calculate the modulus. Okay, so z modulus is represented by this, is equals to root 3 squared 9 plus 4. Okay, so we're going to get root 13 as our modulus. Okay, so we're going to represent root 13 here. Okay, now we just have to find argument of z. Okay, so it is represented by arg z. Okay, so this is it, arg z. Okay, so what we're going to do is the first thing is to find theta. Okay, so this is not argument of z and theta are different. Take a look here. Theta is equals to arctan b over a. Okay, in this case it's 2 over 3. Okay, we can neglect this negative value when you are here. Okay, let's neglect this. Okay, in this case, we're going to get our angle rounded to the nearest one decimal place is 33.7 degrees. Okay, so this is our angle. Okay, so what we're going to do is, this is theta. We're going to draw our theta here. It is angle from the x-axis. So this is 33.7. Okay, but argument of z, remember, argument of z, it is an angle from the positive real axis. Okay, so from the positive real axis going anti-clockwise, we're going to see our angle. Okay, so the angle starts from here and until it reaches this line. Okay, so this becomes our argument. Okay, so how do we represent that? Okay, so here it becomes 180 minus 33.7. Okay, so this becomes our argument. Okay, so this means that our argument of z is 146.3. Okay, this is becomes our argument of z. Okay, so representing it now, we just write this and say 146.3 degrees. Okay, this angle is important on our representation. This modulus is important, and this one is important, and this one is important. All these labels are important. You can leave this angle, but this one is important. But it's very safe to just include all the angles. And writing z here is very important. Okay, so this is how we represent a complex number, or geometrically, or on an Argand diagram. We have learned that this is our argument, and this is our angle from the x-axis, and this is it. Okay, so this is how we do that. Make sure that you remember this formula. Finding modulus of z is equals to a squared plus b squared. Then finding the argument, you just have to look for theta. Okay, finding theta is arctan b over a. In this case, they are all modulus. If it's negative, you just remove it. Okay, so this is it on Argand diagrams. Okay, so this is how we represent them, or geometrically. Okay, now let's go and take a look at what is a polar form. So polar form of a complex number is like this. Let's say you have a complex number, and you found that the modulus of that complex number, number z. Okay, I'm going to use the previous one, which was 3 minus 3 plus 2i. Okay, I'm going to use that. And you have a modulus like this. In this case, it was root 13. And you have an argument of z. In the last case, it was 146.3 degrees. Okay, you can express this in rads if you want. In this case, it's degrees, or in rads. Okay, so if you don't know what is rads, please watch my video when I talked about converting from degrees to rads. Okay, it was very useful to convert from these degrees to rads. Okay, so please watch my video so that you can know how to deal with rads, or together with degrees. Okay, so now let's say you have all this. If you want to express this complex number, I told you that this is a standard form. Okay, so this is standard form. To express it in polar form, we are going to say z is equals to, we are going to take this argument. Okay, we can call it r. We are going to say r cos argument plus I sine argument. Okay, so you're going to take these angles and put here. Okay, so it is going to be expressed. Let's assume that argument of z is equals to theta. It's going to become r cos theta plus I sine theta. Okay, so this is what we call the polar form. Okay, so I think you have understood it. The first thing is to understand you to find the modulus and this argument. After that, you just have to express it. R cos theta, our theta is our argument. I sine theta, our theta is our argument. Okay, so this is it on the polar form, just representing our complex number in this form. Okay, so we're going to see why do we express in this form and how to do it. Okay, so in the next videos it is going to be useful, so make sure you grab this concept, polar form. Okay, now let's talk about Euler form and conclude our lesson. The Euler form is a form of representing a complex number. It is similar to polar form. You just need the argument and the modulus. Okay, so let's say you have a complex number in polar form, which is z is equals to r cos theta plus I sine theta. Okay, remember r is for all these two. Okay, so this is it, our complex number. Okay, so to represent it in this is in polar form, right? To represent this in Euler form, okay, so this is a Euler's form. To represent it in Euler form, it's going to become z is equals to r, okay, I theta. Okay, you don't need to write the sine, you just have to write I sine theta. Okay, so this means that our r is going to come here and this angle is going to come here, as easy as that. Okay, it is very good in radians, it is very simple in degrees. Okay, so make sure you understand it. It's just writing a complex number from this form to this form. You're just taking this argument, this modulus, and this argument and substituting here from this. Okay, so this is was that on polar form, Euler form, and finding of argument. Okay, so next you're going to look at the most important part of these complex numbers, which is the De Moivre's theorem. Okay, so make sure you're in touch and make sure you're subscribed so that you don't miss out on anything.